Okay, so we know a parabola is a parent function of the form f of x equals x squared. Right, that's our parabola parent function. That's centered at the origin and it's facing upward like this. But we also have polynomials, things that are of the form ax squared plus bx plus c. Right, a quadratic or a parabola or a degree 2 polynomial are all the same thing. These are derivations of this parent function. So we're going to be looking at equations that are in that standard form, which is how we're used to seeing parabolas, ax squared plus bx plus c. And then we're going to also look at a new form, which is called Vertex Form. And if you'll look at it, y equals a times x minus h squared plus k. If you'll think back to our parent function definition, I've got x. This minus h is on the inside. It's going to shift the graph left to right. This a that's being multiplied on the outside is going to affect the y's by stretching or compressing them. And the plus k that's on the outside is going to move the graph up or down. Change the y's by adding to them. So this is just derived from the parent function and the transformations we've already been looking at. And this is the standard form that we are used to seeing. So there are some checkpoints that we're going to find when we graph these parabolas. These are what I call the key features or the critical points of our graph. So the first thing we need to know is the direction. Does our graph open upward or downward? So again, it's a parabola, so we're looking for, does it open up or does it open down? Well, we can tell that by just looking first at standard form. We look at the variable a, the number in front of the x squared. If our a is positive, which is greater than 0, then our graph opens up. If that a value is less than 0, then our graph opens down. And you probably have graphed things in that standard form before and are familiar with that, determining which way our graph opens up. So, for instance, if we had something that was f of x equals 3x squared plus 6x minus 2, this would open up because my a is positive. If I had something that looked like, let's call this one g, equaled negative 2x squared plus 6x plus 3. Okay, that graph would open down because the leading coefficient is negative. Okay, and I'm just going to keep talking about this standard form for now. So next is our axis of symmetry. So there's always a line that goes right through the middle of a parabola that if I folded it over that line, I would get the graph lying directly on top of itself. Now, an axis is a line. So we are going to be given the equation for this line. So we know the line is vertical. So I know it's of the form x equals. Because again, I'm given the equation of a vertical line. Those always start x equals. And then to find where that vertical line happens, we would do negative b over 2a. Right, and we may eventually show where this is derived from, where it comes from, but you probably are familiar with that as well. The formula for the axis of symmetry. So, for instance, in the first equation, f of x, it would be negative 6 over 2 times 3, which is 6. So negative 6 over 6. The axis of symmetry would be at x equals negative 1. It would be right here. If I looked at g of x, okay, x equals negative b. So that's negative 6 over 2 times negative 2, which is negative 4. So negative 6 over negative 4 would be at positive 3/2, or 1 1/2, which would be right here, would be the axis symmetry for g of x. Okay, next is the vertex. This is an ordered pair. It is the actual point where the graph reaches its minimum value, or if it opens downward, it's where the graph reaches its maximum value. Those are the vertex. So the vertex always occurs on the axis of symmetry. So we know the x value of the vertex can be found at negative b over 2a. It happens on the axis of symmetry every time. And then to find the y value, we will simply plug in our x value to our original function and find what the y value is. So the way we symbolize that is the y value is f of negative b over 2a, which just means we're plugging that x value, negative b over 2a, in and finding the y value. So we've talked about this earlier. How do we find x-intercepts? X-intercepts happen when the y value is 0. So to find the x-intercept, we're going to plug in 0 for y. And so we get something in the form 0 equals ax squared plus bx plus c. And then we have to solve that quadratic. So we have a couple of ways that we normally do that. We could solve the quadratic by factoring. We'll get down to 2 parentheses and then see what they multiply to give us. And then set those equal to 0. And then some things are not factorable. So the way we would find those x-intercepts is by using the quadratic formula. I'm going to have to abbreviate that there. So hopefully you know the quadratic formula by now. If you do not, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so again, I know I've shown y'all where that comes from before, but if you look at part of this quadratic formula, negative b over 2a, right? Does that remind you of anything? Maybe where the axis of symmetry is located? Yeah, okay. Well, anyways. Next, we're going to find the y-intercept. So if our equation is in general standard form, ax squared plus bx plus c, we find the y-intercepts by plugging in 0 for x. Okay, so I don't remember where I got to, so I'm starting that sentence over. Y-intercept, that occurs when the x value is 0. So we're going to plug in 0 for x. Well, that's really easy when it's in a general form or standard form. So if you plugged in 0 for x, remember standard form is ax squared plus bx plus c. Think what would happen if you plugged in a 0 here and a 0 here. Both of these terms would go to 0 and you would only be left with the c. So when you plug in 0 for x, then c is our y-intercept. Okay, so now we're going to talk about finding all of these same things except for what if my graph was now in vertex form. So again, vertex form, that looks like our transformations that we were working on, where we have y equals a times x minus h squared plus k. So first we want to know, is there a reflector direction? So the direction of my parabola is determined by, was there a reflection or not? So remember, how did a reflection happen? Well, the number out front had to be negative. So this actually fits the same criteria as the standard form. If my A is greater than 0, it's facing upward. That means there was no reflection. If my A is less than 0 or negative, that means we reflected the graph and it is facing downward. Okay, next is the axis of symmetry. So that is the vertical line where the graph is exactly symmetrical about. Oh, that's great to say, right, Cody? That's an axis of symmetry. So it's where the vertex happens again. Well, you got to think the vertex for a normal parabola is at the origin. If I move that parabola up or down, that's not going to affect the axis of symmetry. It would still be the same. The only thing that would change where the axis of symmetry is if I shifted the graph left or right. We shift graphs left or right by this minus h. So again, because this is the equation for a vertical line, it starts off x equals, and then we're going to shift left or right. So again, and remember on the inside it works backwards from how we think it should. So it's negative h, which means if that was a plus 2 inside there, we would be going left 2 to negative 2. If it was a negative 3 in there, we would be going right 3 to positive 3. Okay, next we're going to find the vertex. So the vertex occurs on the axis of symmetry. So the x value would be at negative h. And then the y value would be whatever I get when I plug negative h into the original function. Okay, the next one is where do the x-intercepts happen? And so it's the same idea. You would plug in 0 for y and solve. But I'm just going to be real honest with you. We're not going to normally find our x-intercepts. Well, I say that. If I was given vertex form and I had to find my x-intercepts, I would distribute it. I would make it into standard form. So I would distribute to get standard form. And then I would do the same thing. Okay, so we normally do not like to find x-intercepts from that vertex form. And then the y-intercept, again, if we plug in 0 for x, then we would be given a minus h squared plus k. And so again, we don't normally like to do y-intercepts that way either. So I would do the same as what I did before. I would distribute to get in standard form, and then whatever was the constant c would be my y-intercept. Okay, so I'm given this equation, and I'm told to graph it. So it tells me some things that I'm going to be required to identify. The axis of symmetry, the vertex, x-intercepts, y-intercepts, range, and so forth. But I'm just going to identify all that stuff on my own as I'm getting ready to graph this parabola. So the first thing I notice is this is in standard form. So I want to first know, does my graph open up or down? Well, because the a value is positive, that means that the graph opens up. So that's the first thing I'm going to identify. I know this graph opens up. Okay, the next thing that I would find is the axis of symmetry. So we can find the axis of symmetry by plugging into the formula x equals negative b over 2a. So in this case, that would be negative 6 over 2 times 2, which is negative 6 over 4, which is negative 3/2. So I now know where the axis of symmetry is. So I'm going to put AOS, so I have that in my notes, so I know what that is. Next, to find the vertex, I'm going to plug in -3/2 and find out what the y value should be. So -3/2 squared, that's 9/4. 9/4 times 2 is 9/2.